So today we're going over note 2.6, factoring sum and difference of cubes. So this is a new type of factoring that you really haven't seen. So please make sure as we go through this that you're going to really reference these two equations here that I'm boxing. That's basically what you use to factor a sum and difference of cubes. So these are the formulas we're going to use. There's one for addition, one for subtraction, sum, difference. Notice how similar they are. The only thing that's different are the signs, right? One's plus minus, and then one's minus plus. So to help you remember the signs, because everything else is the same, you're going to remember SOAP. So the way it works is I know it's A, I know it's B, and I know it's a binomial, trinomial, A squared, AB, B squared. It's always that same order every time. The only thing that's going to change are the signs. And if you can remember SOAP, you can remember the signs. So the S stands for same. So whatever you started with, it's going to be the same sign. So if it's a plus that you started with, this is a plus. If it's a minus, it's a minus. The next sign is opposite. So if it was a plus, this would be a minus. And the last sign is always positive. So if you start off with, again, it's a binomial, trinomial. You have A, you have B, you have A squared, AB, B squared. That never changes. So if you started off with a minus, same sign, opposite sign, always positive. And all I'm going to use are those equations over and over and over to do all my factoring today. So example 1, we have x cubed plus 8. So it's going to be a binomial, trinomial. You have A, you have B, A squared, AB, B squared. Remembering the word SOAP. So it's positive, so it's the same sign plus. Opposite sign, always positive. So now all I have to do is figure out what my A and B are, plug them in, and I'd be done. So A is what you're cubing first. So I'm cubing x. B is what are you cubing second? Well, I'm cubing 2, because 2 cubed is 8. So this is my A, this is my B. So wherever I see an A up here in blue, I'm going to put x. Wherever I see a B, I'm going to put a 2. Okay, so it starts off with the binomial part. So we have x, we have 2. It's same sign, so it's plus. Then it's a trinomial. Every time, binomial, trinomial. 2 terms, 3 terms. 2 terms, 3 terms. So you start off with A, which is x for us, and we square it. Next is A times B, so that would be 2x. Next is 2 squared. And then the second sign is always opposite, so that would be minus. The third sign is always positive. So then if we clean this up, x plus 2, x squared minus 2x plus 4. So that's factored. And now some of you might be asking, well, what about the trinomial? Well, good news and bad news. The good news is you can never factor that trinomial. So as soon as you do the binomial and trinomial, you will be done. Bad news is when we solve on the backside, that's going to be complicated. But right now, you're done factoring. That is completely factored. You can't go any further. Okay, next example. So it's a plus. So binomial, trinomial, right? A plus B, A squared, AB, B squared, right? Remembering SOAP. Same sign, opposite, always positive. Same, opposite, always positive. And again, all I'm using is those two formulas that I boxed in blue over and over and over and over. So now what are you cubing? Well, this one's easy. You're cubing 1. But what are you cubing here? What do you cube to get 27x cubed? Well, you're cubing 3x. So this is your A, this is your B. So wherever I see an A, I'm going to put 3x. Wherever I see a B, I'm going to put a 1. That's it. So starting off with the binomial, right? A is 3x, B is 1. It's positive, so this is positive. Now you do the trinomial. You start with A, which is 3x. You square it. Then you do A times B, so that would be 3x, because it's 3x times 1. And then you take B, which is 1, and you square it. And it's the same sign you started with, plus. Right, you got that, good. Then it's opposite, and then it's always positive. So now I just have to clean it up. 3x plus 1, good. Now this is the tricky part, 3x squared. This is where most students mess up, because they get the x squared part, but they want to write 3. No, it should be 9, because it's 3x times 3x. So 9x squared minus 3x plus 1. And again, you might think, oh, I can factor that trinomial. No, you can't. Go ahead and try. You won't be able to. If you can, then you messed up. This is completely factored. This is completely factored. You can't go any further than that. The only other thing that might be there is maybe you had a GCF that you didn't catch at the beginning. Okay, example 2. So again, we're going to factor completely. This time it's a difference. So we have a minus b, a squared plus ab plus b squared. Again, same thing. Binomial, trinomial. Every time. If you can just memorize those two little formulas, the factoring of sum and difference of cubes is actually one of the easier ones. If you can remember those two formulas. There's no guesswork. Okay, so now we got to figure, okay, what are we actually cubing? Well, what do you cube to get 64? It's 4. What are you cubing to get x cubed y to the 6th? It's x y squared. Because if you were to cube that, you get x cubed y to the 6th. So this is your a, this is your b. So a minus b. Then we're going to square a. And then we're going to do a times b. And then we're going to square b. And now we just clean it up. Right? This would be xy squared. Now here's the tricky part. Xy squared squared is x squared y to the 4th plus 4xy squared plus 16. Now again, you're not going to see a lot of them like example 2 here, that first one, but this is just getting you extra practice with the sum and difference of cubes. Usually the ones you're going to see are going to involve, like on a quiz or test, one variable and a number. You're not going to usually have multiple variables because usually we're going to be solving these. That's what we're getting to on the back side. Okay, so this is the difference of cubes, binomial, trinomial. So a squared, b squared. That, I mean, you should just memorize that. And then remember that we should always be using SOAP every day. So same sign, opposite sign, always positive. So next, what are you cubing? Okay, I am cubing a 2 and I'm cubing an x. So this is your a, this is your b. So this would be 2 minus x. This would be 2 squared plus 2x plus x squared. So 2 minus x times 4 plus 2x plus x squared. Now, if you wanted to, that's perfectly acceptable. I'm fine with that answer. But what you might see, like if this was a multiple choice, you'd probably see it written like this. The same thing. I would accept either answer. But like if you were looking up the answers like online in the back of the book or whatever, more than likely you would see it written like this. So again, done 4 of them now. All 4 of them go back to using the 2 formulas at top and remembering the word soap. Wait, last 2 on this page. Okay, so first thing I see is x to the 4th, so that tells me it's not a cube. So now I'm thinking, okay, well, maybe there's a GCF. Maybe there's something I can factor out to make it a cube. So I do see, right, that they're both 250 and 128 are divisible by 2, and they share an x. So what if I factor out a 2x? That would give me 125x cubed plus 64. Well, those are all perfect cubes. So now I can do what I did before. Binomial, trinomial, a, b. A squared, AB, B squared. It's a plus, so same, opposite, always positive. Remembering soap. So now, right, I know there's a 2x out in front. Binomial, trinomial. What's being cubed here? You're cubing 5x and you're cubing 4. So this is your A, this is your B. 5x cubed is 125x cubed. 4 cubed is 64. So this would be 5x, this would be 4. And then this would be a plus sign. Then you're going to square 5x, and then 5x times 4 plus b squared, which would be 4 squared. And now you just clean it up. Not much to do with the first 2, but the trinomial, this would be 25x squared minus 20x plus 16. Again, please be careful with the 5x squared. So many students will write literally 5x squared. No, you're squaring 5x, so it should be 25x squared. This part right here is usually the biggest mistake. Okay, last example on this page. Oops. Okay, so is 343 a perfect cube? Because x cubed 64 and y cubed r. Yeah, 343 is actually 7 cubed. So this is 7x cubed plus 4y cubed. So this is your A, this is your B. So we have binomial, trinomial. So 7x, 4y, this is going to be a plus. So then 7x we're squaring. 7x times 4y, right? And then 4y we're squaring. And the signs, because remember soap, this will be opposite, this will be always positive. So now it's just cleaning it up. So this would be 49x squared minus 28xy plus 16y squared. And when you're writing, like, why did I put the 28 first? Because usually the proper way to write this is the constant, then the variables, usually going in alphabetical order. That's just the proper way that we usually write it. Okay, so that was just a lot of practicing of using SOAP, right? Be able to factor sum and difference of cubes. So now if you flip your notes over, so a blank of f of x equals 0 is any value that makes the equation true. So a solution is any value of x that makes your equation true. So we're going to write our equation in factored form to determine the real and imaginary solutions. So when you set your function equal to 0, you're finding what we call solutions. Those are the values that make that equation true. Okay, so f of x equals x cubed minus 8. What we're going to do, we're going to set that equal to 0. And we're going to find the solutions. What values, real or imaginary, make this equation true? Now what you're going to start to notice is, since it's an x cubed, there's actually going to be 3 solutions. Because I know there's 3 solutions because it's to the 3rd power. Right? That's why x squared, right, it has 2 solutions because it's x squared. That's why x to the 1st power has 1 solution. So whatever, and we're going to learn this is called a degree. That's how many solutions are going to be. So there's going to be 3 solutions. So first we're going to factor it. So again, it's a difference of cubes. So a squared, b squared. You're going to remember SOAP. So minus, so same sign, opposite sign, always positive. Okay, so we're cubing x, and we're cubing 2. So this is going to be x minus 2. So x squared plus 2x plus 4. Right? Because this is x, this is 2x, 2x, 2. So that's basically what we just did on the front side. That's all the front side. So now we're going to go a couple steps further. So we're going to set each factor equal to 0. Because we talked about this. The only way to multiply 2 expressions and their product be 0 is one of them has to be 0. So either x minus 2 equals 0, or x squared plus 2x plus 4 is equal to 0. I don't know which one, but one of them's got to be 0. So this one's easy, right? Add 2 to both sides. That's the easy solution. That's 1. So now when I go to solve this quadratic, I'm going to get the other 2. Because remember, there's got to be 3. Right? There are 3 solutions. Because it's x cubed. 1 from here, 2 from here. Now, remember what I told you about this trinomial on the front side, that you couldn't factor it. So I know I can't factor it. So I know if I can't factor it, then I'm going to have to use the quadratic formula. So this is your A, this is your B, and this is your C. So this is the part where I said it's going to be kind of challenging, because you're going to have to do the quadratic formula. There's no way around it. So minus 2 plus or minus 2 squared minus 4 times A times C all over 2A. And now we just simplify like we did on the last set of notes. So this would be 4 minus 16 all over 2. Coming down here, negative 2 plus or minus negative 12 over 2. So as soon as I see that negative underneath the radical, I know that I'm going to get imaginary solutions. I'm going to get 2 of them, and then I'm going to have the 1 real. So I will have my 3 solutions in a couple steps. So again, simplifying, right, root 12, 4 and 3. So this would be, square root of 4 is 2i root 3 over 2. Because again, I can take the square root of 4 is 2, that comes out, and you have the 3 left. The I took care of the negative. Notice that 2, 2, and 2, they're all divisible by 2. So I can divide them all by 2, and there's my second and third answer. So I got one real solution up in green here that I'm circling, and I have two imaginary, which is a total of 3, just like we said there should be. And what you're going to see as you're doing this is that you're always going to get one real and two imaginary. Because if you were to actually graph this as what we call a cubic, it only crosses the x-axis one time. So there's only one x-intercept. So every time you solve a sum or difference of cubes, you will get one real, two imaginary, every time. One will be easy to do. That would be the real solution, the x minus 2. The other part, you're going to have to do the quadratic formula. It's the only way to solve it. So again, first step, right, factor it. Second step, set each factor equal to 0. Third step is solve it, right? One will be easy. You're going to add, just do a couple of little steps. The other one, you have to do the quadratic formula. Okay, example 4, great example of a quiz or test question you could see. Right, that'd be worth a decent amount of points. Right, so I definitely put a little star next to 4. Okay, now if you're looking at 5, 24 and x aren't perfect cubes, so that means there's probably a GCF. So 24 and 81 are both divisible by 3, and there's an x. So I can factor out a 3x. So that would give me 8 plus 27x cubed. So I'm just going to rewrite that. 27x cubed plus 8. So now I can factor that. That expression, that binomial, is a difference of, or sorry, not difference, a sum of cubes. So that can be factored to a binomial and a trinomial. So remembering SOAP. So same sign, opposite sign, always positive. So what are you cubing? You're cubing 3x and you're cubing 2. So this is your A, this is your B. So this would be 3x and 2. This would be 3x squared. This would be 3x times 2. This would be 2 squared. Because again, remember it's A plus B, A squared, AB, B squared. Now just clean that up. Set equal to 0. So this would be 9x squared minus 6x plus 4. Okay, so now, how many solutions am I going to get? How many values are going to plug in for x and give me 0? Well, it's going to be 4 solutions because it was x to the 4th. So there's going to be 4 solutions. The last one, there was 3 solutions because it started off as x cubed. All the quadratics were x squared, so there were 2 solutions. Okay, so I'm going to set each factor equal to 0, and I'm going to solve. So there are 3 factors, so 1, 2, 3. So 3x equals 0, divide by 3, so x equals 0. 3x plus 2 equals 0. Subtract 2, divide by 3. There's your second solution. So I have 2 real solutions. And now I'm going to have to do the quadratic formula to get the 2 imaginary. So I have half my answers. I have 2 out of the 4. So I have my A, B, and C. So minus a minus 6, plus or minus 6 squared, minus 4 times A times C, all over 2A. And now I'm just going to simplify all of that. So 6 plus or minus 36. So now, right, I have to do 4 times 9 times 4. So that's minus 144. And then I just keep going. So 6 plus or minus. So I get 36 minus 144, negative 108. Okay, so there is my imaginary. And then I'm just going to simplify it, just like we did up top in the blue part in example 4. So negative 108, if you simplify that, you get 36 and 3. All right? So you can take out a 6. So this becomes 6 plus or minus 6i root 3 over 18. So again, root 108 is 36 and 3. Square root of 36 is 6. The I takes care of the negative. Notice again, all divisible by 6. So 1 plus or minus 1i root 3 over 3. And there's your third and fourth answer. So there are your 4 answers. 2 real, 2 imaginary. We knew there were 4 solutions to begin with because it started off as x to the 4th power. So as you're doing these and you see these examples, so you set them equal to 0, you factor, you set each factor equal to 0. Whatever degree you start with, the largest exponent is how many solutions you're going to get. Make sure you go back as you write your summary, you're answering your essential question at the top of